Hi everyone. So in this lecture we'll see how you can count the number of set bits in a particular number. So what are set bits? Set bits are those bits which are 1. For example, if I give you the number 9, which is like 1001, then I can say it has 2 bits which are set bits. So I want to count the number of set bits in the binary representation of any number. That's what we need to do. So let us see how we can approach this particular problem of counting set bits. So let us discuss the approach. So it's pretty easy. So we know the number is stored like this, and we also know how we can find out the last bit. So we can do a AND with 1, and this will tell us what is the last bit. We will get to know, okay, this bit is 1. And for the next iteration, what we can do, we can remove this bit by doing a right shift. Okay, so we can say the last bit is n and 1, and if this bit is 1, then I will increment the count of my set bits. If it is 0, I will not increment the count. Okay, or I can simply write, let's say initial count is 0, then I can say count plus equals to n and 1. So if the last bit is 1, then count will increment by 1. If the last bit is 0, the count will increment by 0. And I want to remove this, so I can say n equal to n right shift 1. Okay, so next time you will get 1 and 0, it will be 0, count will change by 0. Next time it would be, you remove this one, 0 and 1, it would be still 0, so count will change by 0. Next time you remove this 1 and 1, it is 1, so count will increment by 1, so final count would be 2. Okay, so this is what we can do. So I can write a function count bits, I get the number n, and here I can say while n is greater than 0, what I can do, every time find out the last bit. So I can say int last bit, I don't know, or maybe I can say int count, that is 0, and here I can find out the last bit. So last bit is nothing but n and 1, and I can say count plus equals to last bit. Okay, if it is 1, count will change by 1. If it is 0, count will not change. And then we can do is n equals n right shift 1, and from here we can return the count. So here we go. So what I can say, int n scene n, and I can say cout count bits of n. That's it. And I hope this is now clear to you. And what we are doing is, we are doing a very simple operation. Every time we are doing a right shift, okay, so we do a AND here, this goes off, next time these two bits interact, okay, and finally we will get a 1 here. So this 1 is added to the count. So this we will do for all the bits, and for a number n, at most the number of set bits is going to be log of n. Okay, so the number of times this loop is going to run, it is going to run at most log of n times for a number n, because a number n has log of n bits. That you can easily verify by taking some examples also. Let's say 16 is like this. So 16 has, like, it's like 2 raised to the power 4. It would have at most 4 plus 1, that is 5 bits. Okay, talk about 7. So it's going to be around 2 raised to the power 3. So 7 is going to have at most 3 bits. So log of 7 is close to 3. Log of 16 is close to 4. So that's what I'm trying to say. So for any number n, you have at most log n bits. And okay, count is not declared, so this should be cnt. And yes, we are done. And now we can actually run our code and see. So /count bits, if I give 16 has only 1 bit. If I give 15 has 4 set bits. If I give 8 has also 1 set bit. So that's all for this lecture. Thank you.